this video, we're going to look at exact value triangles. By exact value triangles, we mean relatively simple triangles with, let's say, nice angles and nice lengths in them that we can use to quickly figure out what sine and cos and tan of certain common angles are without having to necessarily use a calculator. So you'll see what I mean. So let's consider the following triangles. So our first exact value triangle is the triangle such that it's a right angle triangle. So this is the right angle, and these two sides here are both length 1. So the two shorter sides are both the same length and they're both length 1. And by Pythagoras Theorem, that makes the hypotenuse root 2, because we do 1 squared plus 1 squared, which is 2, and that equals the hypotenuse squared. So therefore the hypotenuse is the square root of 2. So we know all the side lengths in here now, and we also know these two angles that aren't the right angle. They must both be the same, since this is an isosceles triangle, because these two sides are the same length, 1 and 1. So both these angles here are the same, and they must both equal 45 degrees, because the third angle, the right angle, is 90 degrees, and all three angles have to add up to 180, because in any triangle, the three angles always add up to 180 degrees. So if one of them is 90 and the other two are equal to each other, they must both be 45. So we can use this triangle to write down what sine, cos and tan of 45 degrees are. And this will come up quite a lot. So knowing sine, cos and tan of 45 is quite useful. So you don't have to always put it into your calculator, and sometimes you might get asked problems like this specifically on a paper where you're not allowed a calculator, because you should either just know these things from memory or at least be able to figure them out using a triangle like this. So sine 45, remember sine is opposite over hypotenuse. Remember SOHCAHTOA, S-O-H. So the opposite to 45, you can pick either of the two 45 degree angles in this triangle, it doesn't matter. The opposite is 1 and the hypotenuse is root 2. So we get sine of 45 is 1 over root 2. Similarly, cos of 45 is also 1 over root 2, because cos is adjacent over hypotenuse. The adjacent to both of the 45s is also 1, and the hypotenuse again is root 2. And then tan, remember TOA, so tan of 45 is opposite over adjacent. Both the opposite and the adjacent to either of the 45 degree angles here are both 1. So the opposite and the adjacent are both 1. Therefore, tan of 45 is 1 divided by 1, which is 1. So you can see, if you can remember this triangle, which it's not too hard to remember, because as long as you remember it's a right angle triangle where the two shorter sides are both 1, then you know the hypotenuse has to be root 2, and you know the other two angles have to be 45 degrees. So you write all that down, then you can quickly write down what sine, cos and tan of 45 are. And that can be very helpful if you're doing a problem and you don't have a calculator, or you're not allowed a calculator and you need to know sine, cos or tan of 45. So we'll do the same thing with a different triangle. So our other common exact value triangle is this one, where we have now an equilateral triangle. So it's not a right angled triangle. All three of the angles are equal, and in any equilateral triangle all three angles have to be 60, which I'm going to note now. And for this one we're going to say the length of each side is 2. So an equilateral triangle is a triangle where all the angles are the same and all the sides are the same length. And this one we say they're all length 2 and the angles are all 60, because they have to be to add up to 180. So now what we do is let's remove some of that information, just keep one side length and one angle labelled, and let's draw a line at a right angle to the base. So this is similar to what we did in the last video. We create a right angle triangle from this equilateral triangle. Now this line must be cutting the top angle in half, and it's cutting the base in half, the base of the triangle. So the top angle, remember the whole angle is 60 degrees, so just half of it is 30 degrees, and the length now of the bottom of this triangle is 1, because the length of the base was 2, so half of it is 1. So now if we just think about this half triangle we have here, half of this equilateral triangle, it's a right angle triangle, and we have all the information, all the side lengths. We just need to use Pythagoras' theorem to get the third length that we don't have currently labelled, which is √3. Because if you think about Pythagoras' theorem, this side squared plus 1 squared has to equal 2 squared, because 2 is the hypotenuse. So it must be √3. √3 squared is 3, add 1 squared, which is 1, that's 3, add 1 is 4. Take the square root of 4 and you get 2. So we now have all the information on this triangle, so we can write down sine, cos and tan of 30 degrees and 60 degrees. So remember, let's do 30 degrees first. So sine is opposite over hypotenuse. The opposite to 30 degree angle in this triangle is 1 and the hypotenuse is 2. So sine of 30 equals a half. Cos is adjacent over hypotenuse, so cos of 30 is √3 over 2, because the adjacent to 30 is √3. And the hypotenuse is once again 2, and then tan is opposite over adjacent, so that's 1 over √3. So I'm just pulling these off my diagram. And then we can also do sine, cos, tan of 60 in the exact same way. So sine 60 is √3 over 2. That's opposite. So sine SOH, S-O-H, so it's opposite over hypotenuse. So √3 over 2. Cos is adjacent over hypotenuse, so that's 1 over 2. And tan is opposite over adjacent. So the opposite to 60 is √3 and the adjacent is 1, so that's √3 over 1, which is just √3. So tan of 60 equals √3. So once again, you can hopefully remember this second triangle. You don't necessarily have to remember the whole thing, you just have to remember that if I draw an equilateral triangle with side lengths 2, I know all the angles are 60, then if I cut that in half and create a right angle triangle, I can write down all this information, and I can therefore find sine, cos and tan of 30 degrees or 60 degrees, and using the first triangle 45 degrees without a calculator. And this can be very handy.